Welcome to Math 31. These are just a few more limit questions. Not breaking a lot of new ground, maybe just with a couple ones that are really noteworthy. Feel free at any point to pause me and to go through the questions and then check your answer with what I get. I really encourage you in this case. So big thing is you substitute in and you see what you get, and that tells you what to do next. So when I am taking the limit as x approaches 1, I get 1 over 1 minus 1, which is 1 over 0. So therefore there is no limit. Simple as that. So that's a recognizable graph as well. This would be a reciprocal function. Now the next one, we saw something like this earlier. And when we saw it before, it was the same question except it was plus 2. And we substituted it in, and we did get a non-zero number over 0, so there's no limit. In this case, I won't waste a lot of your time, but if you do replace the x in with 0, you will get 0 over 0, which means we must go on. And we get around this little problem by rationalizing the numerator. That's why you learned how to do this earlier. So we multiply by the conjugate, the root of 4 plus x plus 2 over the root of 4 plus x plus 2. And a minus b times a plus b is equal to a squared, which is 4 plus x. I'm putting a bracket up even though I don't need it, minus b squared, which is 2 squared, 4. All then, this is the limit, by the way, as x approaches 0. All then multiplied by x times the root of 4 plus x plus 2. As we go further, 4 plus x minus 4, the 4's are going to cancel and we have just x. And that's going to be x on the denominator multiplied by 4 plus x plus 2. We divide out the x's now, and we have the limit as x approaches 0 of 1 over the root of 4 plus x plus 2. Take the limit, plug it in, and you will get equal to 1 over 2 plus 2 is 4. So this limit is equal to 1 over 4. And I don't really have room to put it at the very beginning. So an important method that you use frequently. Now the next thing, this one doesn't break much ground. In fact, it doesn't really do much of anything. When we substitute it in, we will get negative 2 plus 2, take the limit, negative 2 squared plus 9 gives you 0 over 4 plus over 13, which is just equal to 0. So that's the limit. So we would be approaching the x-axis, for what that's worth, if you were to graph it. Number 4, another one that if we substituted it in, again, pause me and go through it and check, but if you did work this one out, you will get 0 over 0. And when I see that radical, I know that the best solution probably would be to rationalize. So root x plus 2 over root 8x plus 2. And I like to go directly to the a squared minus b squared part. And that will give me 8x minus 4. And then the denominator, do not distribute it in. You've just got 2x minus 1 times the root of 8x plus 2. Now we do not see that cancellation immediately, but on the numerator you'll see very soon, by factoring a 4 out, you'll get 2x minus 1, and then 2x minus 1 being multiplied by the root of 8x plus 2, and then all of a sudden things open up for us. 2x minus 1 we divide by, and so we have 4 over the root of 8x plus 2. And then this is the limit as x approaches 1/2. When we take the limit, we will get 4 And then the denominator, 8 times 1/2 is 4. Root of 4 is 2 plus 2 is 4. So it's actually equal to 1. No, not a great way to write it, but that's, we could do it in a number of places. Equal to 1. Just so it's clear, that's all that matters. Now, the next problem is sort of what we've seen earlier, back in the previous one with the substitution, because when you try to solve this one, you're going to notice pretty quickly that no matter what you do, first off, let me back this one up, you will get a 0 over 0 situation. So you know it simplifies. It has to. So you just need to find a way. Now, if this was a square root of x, then you could rationalize it, because the root of x would be x, like x to the 1/2. But it's not. The cube root of x is not going to rationalize the same way. So we have to find something that works. And this might help. Actually, I'll go down. This might help. If you factor the 2 out, this becomes x plus 1. And then with the other part, the denominator, if it made your life a little bit easier, you can see that this is x to the 1/3 plus 1. So some of you are thinking, okay, I can tell that this might be a substitution question, because it's just a little, I can't see exactly what to do. So if you take your awkward part, the x to the 1/3, and let, say, u be equal to x to the 1/3, then it means that our denominator is u plus 1. And once again, we've got this one set up in terms of two variables, but that's okay for now. And then if you were to cube both sides, you'd get x is equal to u cubed. So this is 2 times u cubed plus 1. And we can see now it's a sum of squares, or sum of cubes. And that sum of cubes will factor into u plus 1, then u squared minus 1u, and then plus 1 squared is 1, all over u plus 1. These divide out, so we have the limit of 2 times u squared minus u plus 1. And then we note that the limit is defined in terms of x. So x is equal to u cubed. Now, if u cubed is equal to, approaches 1, I should say, negative 1, this could be simplified if you took the root that u must be approaching negative 1, cube root of both, and then u squared minus u plus 1. We should be able to now take the limit with no problem. We have no denominator. So this is 2 times negative 1 squared minus negative 1 plus 1. So 2 times 1 plus 1 plus 1. So that's 3 times 2 is equal to 6. Okay, so watch out for that. Now you're probably thinking as well that this connection could have been made, that there's a difference of, or sum of cubes, because we did that earlier with one of the factoring questions. So if you saw that, you didn't need a substitution. If you didn't see it, well, then the substitution is a good idea. Because really the idea behind substitution is to help you get a different look at the question and see it for what it is when it's not so apparent from the original setup. So that's going to take care of that. The next lesson will be on getting one-sided limits, which pushes us back a little bit. And then we just play around with that sort of thing for a while, get onto review some of the other topics that we've done before, like continuity, but just looking at them in slightly different ways. Thank you for your time.